Okay, welcome. So today we're going to be working with multiplying and dividing rational expressions. Our goal is to learn how to simplify rational expressions. So have a go now at this do now. Pause the video if you're following at home.
Hi, sorry to interrupt. Comment? Okay.
Okay, let's have a look at what we should do. So firstly, we need to identify any excluded values. Our excluded values are going to be in the form x equals. So it's anything that's going to make the denominator equal to 0. So we can see if we put an x equal to minus 3, we would make it divide by 0, and that is an excluded value. Make sure you understand the difference between stating an excluded value and stating the domain. The domain is x is not equal to -3, but the excluded value is x is equal to -3. This is also, if we graphed a function with this expression, it would be the vertical asymptote. So next up we want to factor. We've got x plus 3, x minus 3, multiplied by 9x, over 3x plus 3. Now we can cancel common factors. X plus 3 is a common factor, and this 3 cancels that 9. That's going to leave us with 3. That's going to leave us with 3x squared minus 9x. Alright, have a go at this question now. I'll pause the video. Alright, let's have a look at our factorization. So we want to start by factoring. This one's going to be 3x squared, and then we're going to get 2x minus 5x plus 2, and then here we're going to get x minus 4, x plus 2, and then here we're going to get x minus 5, x plus 2. So if we factor it like this, we can see what our excluded values are. So don't cancel anything until you identify what your excluded values are. So x is equal to, I'll do it from the smallest, so minus 2, 4, I'm saying 4, I'm drawing the line. Minus 2, 4, and 5. These are our excluded values. So we can cancel now. This is going to cancel these two. And we're going to be left with 6x squared over x minus 4, x plus 2. Okay, start off by having a go at factoring this one. Alright, so we start by factoring. This is going to give us x plus 7 squared over x squared divided by, so to factor this one we get x plus 7, x plus 2. And then to factor this one, we're going to get x plus 2, x minus 1. What we need to do at this point is start collecting our excluded values. Alright, so what excluded values do we have here so far? We have 0, -2, and 1. So now in order to do this, we need to do a keep, change, flip. But if you want, we don't have to include this anymore. We can take these off, they're going to cancel. These two are going to cancel, and we get x plus 7 squared over x squared multiplied by x minus 1. And this one's going to be multiplied by x plus 7. At this point, continue to look for excluded values. Negative 7. Notice now that this is in the denominator. So negative 7 is an excluded value.
You keep down like the excluded values as it is, and then you solve it and then you find new ones.
So these are the excluded values at this particular point, and we make this multiplication. This is an excluded value.
So it's all that's excluded.
Yeah. Yeah. So now we can look for any more cancellations. This and this are going to cancel. And we're going to be left with x plus 7, x minus 1 over x squared. Just never know what the examiner wants, I'll just expand that one. It's not going to be too bad. So plus 6x minus 7 over x squared. And we're finished.
Oh, wait, so why don't the exclude cancel?
Because they're not being multiplied.
Yeah, why don't?
It's just they're dividing the whole equation, it's not just x squared.
Okay, a really common misconception,
Okay,
and quite a heinous misconception, is this one. This could not be more mathematically wrong.
Because then you have to divide 6 as x.
To explain to some extent why that must be quite badly wrong, this expression can be rewritten like this. If you think about how we add and subtract, this expression can be written like this. If you wish to separate it up, this expression can be simplified to. My pen's going a bit funny there. These are all equivalent expressions. These are all
So
equivalent
if it doesn't
expressions.
simplify fully, you'd want it like that?
I would want it like as a single quotient,
Okay.
yeah.
like this. Typically, I like it like this. I always like factored forms. You can see and identify a lot of things in the factored forms.
So, before we flip it, we're looking for the excluded value.
Yeah. So you look for the excluded values twice on this one.
Okay.
All right. Have a go now at this modeling question. So listen to me carefully. Start by trying to make a function. If you make the function, have a go at finding the domain and range of the function. And then solve. I want you to go through all of those steps. So let's explain this thinking. We've got our current solution is 6% solution. So 6% solution is 6 over 100. This is our percentage. This has to be made with 500 grams of 500 grams of saline solution. So how much salt is in that? How do we turn the 6%? 0.6%.
Multiply by 30. 0.1?
So 6%, 6 over 100.
Yes.
We want 500 grams of saline solution.
That's 5.
So how much salt is in our saline
Multiply by
solution?
5.
30.
30.
Okay. So we need to make our function that will allow us to output the amount of the percentage. So we can say this is P of 0. So we're going to make our function P of x is equal to 30 over 500 And we're going to add X grams of salt to this. So 30 is how many grams of salt?
6.
So here in this one, 30 grams salt, 500 grams solution. So our new function is we're going to add 30 grams of salt, which means we also have to add 30 grams to the solution. So both the amount of salt will go up and the weight of the solution will go up. They'll both go up by x. This is our function now. What is the domain of this function?
X
Negative
to negative
5.
5.
X is not
If
equal
it's
to
not
negative
equal
five.
to
Okay, please explain. Now this is where you'll lose points for modeling questions. This is where you'll lose points. How do you add negative 500 grams to a saline solution?
Grams, it's negative grams, that doesn't make sense.
You remove.
How do you add a negative? Can you pull salt out of water?
No.
No. So, what is the minimum value of x?
0.
Zero.
There. You have to, with modeling questions, interpret from context sometimes. Don't just look and think, okay, x cannot be negative 500. It has to make sense. So x has to be greater or equal to 0. Think about the 0 threshold as well. Can you add no amount of salt?
Yeah.
Yes, we can add no amount. Can we add an infinite amount of salt? Well, probably not, but in theory. What is the range of values?
So opposite.
What is the range of values?
0.
Oh, that's not the.
Orange is the 30. I think it's 30. Is it 30? I feel like it's 30.
0.0.
No. So what does P of x tell us?
The
Percentage concentration. What is the current concentration?
30.
What is the current concentration? 6%. By adding salt, can we lower that?
No. And you can only go up to 100%, so it's 6 to 100.
What?
6% to 100%.
Just take it. Oh yeah, I sent you a picture.
We can go from 6% up to and including
Don't worry.
100%. We can't, well, we will never get to 100%.
Okay.
Let's say in the test we were to put including 100, would we lose marks for that?
Possibly, yeah.
Eliminate concepts.
If you think about this, can we get to 100% by adding salt? We'll approach 100% as we approach infinity. But that's getting a bit stupid, doesn't it? So this is the range of the function. So when in a modeling question, you'll be asked to state the domain and range. State the domain and range. You're going to have to think this through from context, not just by looking at the function in isolation. It has to make sense in the modeling context. So lastly, how much salt should we add in order to bring it up to 20%? So finally, we want to create 20%. So 20 over 100 is equal to 30 plus x over 500 plus x. That simplifies on the right, on the left-hand side to 1 over 5,
20%.
which means you can write this as,
20% solution.
sorry, I'm running out of space. So I'm going to multiply 5 by both of these. What's 5 times 30?
5 times 3 is
150.
150 plus 5x is equal to 500 plus x. We've got 4 x's on that side, and how much is it? 350 here? Is that 350?
Yeah.
Divide through by 4, we get x is equal to 350 over 4. Is that 87 or something?
87.5.
87.5. What's the units? What's the units?
Ground.
Percent?
What does x represent?
Percent.
No,
So you have to convert it?
How much salt should be added?
What does x represent?
How much salt should be added?
The mass of salt.
the ground.
So grams. Don't randomly throw up units, percent and things. Think with a modelling question, you must connect to context. You must know what P of x stands for, what the units are. You must know what x stands for, what the units are. Alright. So have a go at the IXLs assigned today. You need to get 3 of them done for your exit ticket.
Oh, 3 questions.
So you said 3 Excel.
You open the Excel and